In a previous video, I told you I was building an AI voice clone of myself as a health accommodation for sickle cell disease, and that my initial tests showed the technology wasn't working well for my face or my voice. Today, I have more data. I've completed systematic testing across 3 voice cloning platforms and 4 video avatar platforms. I want to give you the specific findings because specific findings are what the governance conversation needs, not impressionistic observations. Data, Section 1, Methodology. Here's how I ran the tests for voice cloning. I recorded a standardized input, same script, same room acoustics, same microphone, same distance across all 3 sessions. I then generated output using the default settings on each platform. Then again, using custom configurations I developed through iterative testing. I compared output quality against the platform's own demo voices using the same evaluation criteria: tonal accuracy, harmonic fidelity, the retention of voice-specific characteristics. For video avatars, I used a standardized reference image taken under controlled lighting conditions. I generated output and compared skin tone values in the avatar against values measured in the reference image using colorimetry tools. I ran parallel tests with lighter-skinned comparison subjects to establish whether any difference was due to my specific image quality or a systematic effect. Section 2. Voice Findings. Voice Cloning Results. All 3 platforms showed measurable accuracy gaps on my voice relative to majority demographic demo voices. The degradation pattern is consistent across platforms, which tells me this is a training data issue, not a platform-specific engineering issue. The specific qualities where accuracy drops: tonal richness in the lower registers, the warmth in my voice that people who know me recognize immediately, harmonic accuracy on sustained vowels. The AI approximates the shape of the vowel, but smooths out the specific overtones that carry my vocal signature. Episode 3 comes soon, and we'll cover more voice data dimensions. I'll be adding the AAPI voice data dimension to the findings, links in the description. The clone produces a more metronomically regular output. It sounds like a version of me that has been flattened toward a standard cadence. After 11 different configuration iterations across the 3 platforms, I found one platform with one configuration that produces acceptable output for basic audio content. I define acceptable as a listener who doesn't know my voice well would not immediately recognize it as synthetic. A listener who does know my voice would hear the difference immediately. The hours required to reach acceptable, approximately 40 across 8 weeks. Not scalable for a non-technical user. Section 3, Avatar Findings. Video avatar results. All 4 platforms lightened my skin tone in the output. I measured this quantitatively, taking the average skin tone value from my reference images, measured using standard colorimetry scales, and comparing to the avatar output under matched lighting conditions. I found consistent lightening ranging from subtle to moderate. I ran parallel tests with lighter-skinned comparison subjects to establish whether any difference was due to my specific image quality or a systematic effect. 2 platforms produced a finding I want to name separately from the skin tone issue because it is a different failure mode. The avatar those platforms generated was masculine, not a lighter version of my face, a different face, different jaw structure, different brow architecture. The visual cues the model associated with authority given a voice and credential profile like mine. The system made a gender inference. It was wrong. One platform, when I provided my name and professional title as context, generated an avatar of a different race. The model read my credentials, constructed the most probable demographic for those credentials, and generated that person's face. Not mine. I want to be precise about what these 3 failure modes are, because they require different governance interventions. Skin tone normalization, a training data distribution problem. The model learns skin tone clusters toward a demographic center and applies that normalization to outputs. Gender misclassification, an inference problem. The model maps credential and voice profiles to demographic assumptions and constructs a face based on who it thinks is most probable. Racial inference error, a contextual inference problem. The model reads name and professional context to infer race and generates accordingly. Same structural cause training data that underrepresents dark-skinned Black women in positions of credentialed authority. 3 different outputs, all 3 documented, The gender and race inference problems appear to be in the model weights and are not configurable away. The lip sync alignment, also tested across platforms, showed more errors on my face than on the comparison subject. Closing. Forward. What comes next? What do these findings mean for organizations? If your company is deploying voice AI or avatar AI for customer service, for employee productivity tools, for accessibility features, and you haven't tested accuracy across your demographic range, you have a gap you haven't measured. The gap I'm finding is not unique to my voice or my face. It is the predictable outcome of building systems on training data that underrepresents dark-skinned, accented, and non-majority demographic voices and faces. Test your tools. Require demographic accuracy breakdowns from your vendors. Don't accept aggregate performance metrics that hide the differential. The full technical report, platform names, configuration details, and methodology publishes on drday.substack.com this week. Episode 3 comes in 2 weeks. I'll be adding the AAPI voice data dimension to the findings, links in the description.